Topic: Simple and Multiple Linear Regression. Data Set 1.
Prepared by
In a prior discussion, we reviewed simple linear regression, which used a single predictable variable x to describe the response of variable y. There are 27 data of all green franchise that sells house plants as well as lawns and garden goods. Variable comes in two varieties. The first one is dependent variable and the second one is independent variable. Remind, the variable is what is being examined. In many applications, the response is influenced by a number of different factors. Hence, multiple regression models explain the linear relationship between a single response variable y and a number of predictor factors.
For 3.1, the scatter plot, we can see that for x1, x2, x3, and x4, it has an increasing trend, while for x5, it has a decreasing trend. For the correlation coefficient, for x1 is 0.894, x2 0.946, x3 0.914, x4 is 0.954, and x5 is negative 0.912. The general form of simple linear equation for x1 is y equals to 85.39x plus 2.58. For x2, y equals to 0.95x minus 81.5. For x3, y equals to 46.51x minus 90.15. For x4, y equals to 35.64x minus 58.82. For x5, y equals to negative 35.79x plus 563.59. The slope for x1 is 85.39, x2 0.95, x3 46.51, x4 35.64, and x5 is negative 35.79.
Next, the coefficient of determination is determined by looking at the R-square. The higher R-square is x4, which is 0.91. This shows that all green franchise has a larger size of cell district per 1,000 families, which is 0.09 is unexplained by the model. Multiple linear regression. Overfitting. The overfitting from the scatter plot shows that it is a positive correlation. The correlation is high while the p-value is low. This makes us able to conclude that there is a strong correlation and it is statistically significant. Multicollinearity. By looking at the VIF from the coefficient table, as we know, if the value exceeds 5 or 10, it shows that it has a high multicollinearity between this independent variable and the others. As we can see, x2 until x5 have a high VIF value. This means that they can be predicted by other independent variables in the data set. Model comparison. Models are chosen based on their R-square. The R-square for multiple linear is 0.93, which is higher than the other R-square, while the lowest R-square is x1, which is 0.79. The model with the higher R-square is better to be chosen.
Okay, so next we look into the 3.9, the best fitted model. Based on the comparison of a model in 3.8, we found that the most suitable or fitted model to predict is multiple linear regression, because the standard error for this model is in a small bandwidth. Also R-square and adjusted R-square in the high value, so it is indicate a good level of prediction. The next point is 3.10, point prediction based on the best model. As shown in the table, dependent variable y has a negative value and the independent variable has a correlation because x1 until x4 is in a positive value except for x5. This shows that when the value of x1 until x4 increases, the y will be increased, but for x5, the value of y will be decreased by negative 5.57 units. The last one is hypothesis testing. This hypothesis testing is done to see if the independent variable has an impact on the dependent variable y. We look into the significant part. The value for independent variable is smaller than 0.05, so it has a significant effect or contribute to y.
As a conclusion from the results of the study we have conducted on single linear regression and multiple linear regression data, we found that the most suitable or fitted model to predict the value of the dependent variable hinge on the value of the independent variable is multiple linear regression. It is because MLR could trace the strength of the relationship between the outcome, which is the dependent variable. Also, the standard error for this model as well as the R-square is indicating a good level of prediction, and the adjusted R-square is in high value compared to single linear regression, which only looks at linear relationships between dependent and independent variables and is sometimes inaccurate in making predictions towards the data.